All right. So welcome everybody to your weekly drone date. Louise and I love to welcome our members and anyone who's joining for the first time to our weekly Fireside Chat with Women in Drones Africa. This is our platform where we welcome anyone who is able to share information, who's able to inspire. We laugh, we cry, we inspire, we get inspired. We have some new peeps on the Fireside Chat. And also, we have a really good friend in the industry on today, Robert Miller. We are so privileged to have been following Robert and his team's journey in anti-poaching, and not only the anti-poaching activities, but also this process and journey of designing and building an anti-poaching drone. And I have seen Robert present. I've felt and touched parts of this drone, and we are willing this drone to be born. And Robert agreed to come on Fireside Chats today to update us on where we are in the process and what's been happening and what's not been happening. And Robert, as I said, it's an absolute pleasure having you on. And I'll hand over to you, and the floor is yours.
Thanks, Kim. Maybe we should just keep it very casual today because it's a small group.
Totally.
Yeah. So do you want me to just run through the presentation about the project or just generally chat?
Whatever you're comfortable, but may I just stop this conversation and welcome your cat? Because Robert's cat features in Robert's cat features in many of his videos. Is this the cat that used to come and kind of walk past your face?
No, that's Salt. This is Pepper.
Oh, that's Pepper. Okay, it's Salt and Pepper. Hello. Robert, any which way you like. The presentation was great, but just chat us through whatever you're more comfortable with.
So let me run through the presentation. Anyone got any questions, just stop me as we go.
Perfect.
So let me see if I can share my screen. Kim, I think you need to give me permission to share the screen.
Let me just see. Hold on one second. Here we go. There you go. That should work.
It should start now. Okay, now let's just see which screen it is. Okay, yeah, that one there. Okay, can you all see the
We can.
screen?
Yes, we can.
Yeah, I'm just trying to see what's going on here quickly with Zoom because it tends to minimize itself. Come on. Okay, let me just carry on with it like this. So a while ago, we were wondering why drones weren't used in anti-poaching. I mean, they were a very valuable asset, and I think with Ukraine, we're seeing just how valuable drones are, and how drones are coming into their own and changing the way we do surveillance. So, sorry for the pictures, but we're losing the war against poaching on all fronts. It's overwhelming the resources, and the losses are just increasing. So a few years ago, we decided we needed to change this. We needed to build a drone that was going to allow the people on the ground to have an advantage over the poachers. I think Kim's seen this, but for those of you who haven't. So in the beginning, we were very, very naive. We thought we could buy an off-the-shelf solution, little Skywalker, put it up in the air, and it would allow us to track poachers. We realized very, very quickly that wasn't going to work. Luckily, we realized very quickly, and the next thing we did is we tried to build on the experience of the projects that preceded us. I think that's what one tends to do. I'm just going to stop my video to get a bit more bandwidth here. Or actually, no, never mind. When things don't work, you look at what everyone else has done and you try and learn from what everyone else has done wrong. Somewhere along the line, we realized this wasn't the right approach. Okay. The general opinion was drones don't work in the anti-poaching arena, and we couldn't understand why. So fortunately, we are extremely stubborn. We don't give up very easily. And one of my favorite quotes, wisdom comes from experience. Experience is often a result of lack of wisdom, from Terry Pratchett. If we had had the experience in the beginning, we would have had a lot more wisdom, but it was very much a case of trial and error. So what we did is we went back to basic and said, okay, if a drone is going to succeed in the South African arena or African arena, what does it have to be able to do? Not what's available, because then you try fit what you have into what you need. We said, what do you need? And after a lot of research, the features that we needed were a drone that was designed for the African terrain and weather. It had to handle everything from heat to cold to dust to rain to wind. It needed a long flight duration, which meant a fixed wing. It had to take off and land autonomously, which meant vertical takeoff and landing was a must. Respectable payload, battery hybrid power, autonomous execution of mission plans. It had to be equipped for beyond visible line of sight flights. It had to have minimal ground crew, an onboard AI for analysis of camera and sensor data. And this was a critical one. What came back is when people sit and look at a screen for 4 or 5 hours, they start to miss things. You can actually have someone run across the screen and someone who's been staring at it for hours will miss them. We had to have the ability to autonomously identify and begin tracking a verified target and minimal on-site maintenance. Sorry, that slide wasn't up. So there are no perfect solutions, only trade-offs. Luckily, we had the dream team. We had Dr. Becca van Niekerk as our aerodynamic consultant, David van der Merwe as our director of airframe engineering, and Carl Crick as our director of simulation. We were lucky that we had industry partners. SolidWorks came on board with their CAD software very early on. MeCAD, who are the local SolidWorks agents, gave us full support whenever we needed it. Flying Robot, little company in Cape Town in the drone industry, managed to source everything we needed, even the hard to get parts. And then AOC came on with their large screens. When you're working on a very large drone, there's lots of parts and lots of components working together. So we needed real estate. And people always ask me, just how big is the screen? Just to give you an idea. It's 49 inches. I actually have to move my head from side to side to see the full screen. So getting back to the drone, what we decided to do is to produce a unique, fully 3D printed fuselage. Prototyping is expensive and making changes once you've made molds is expensive. 3D printing potentially offered the solution to that problem. So after thousands of hours of CAD work, and literally thousands of hours and hundreds of hours of simulation, we realized that most of the 3D printer manufacturers have lied through their teeth. We actually went as far as doing CT scans of the printed parts to verify them. And most of the big players, their tolerances are not what they promised. So it was a lot of going back, redesigning, re-engineering to try and figure out how to work around the actual tolerance of these machines. That was many long days and nights in front of the screen. So Kim, that is Salt. He's always there. He's always supervising everything I do. One of the things that was really important was a modular airframe construction. I think one of the things that most of the people in industry will know is the CAA and most of the aviation authorities are very pedantic about maintenance. And we can understand why. So we wanted a drone that was modular, where you don't actually do repairs in the field. You literally unclip modules, clip in new modules, and send the modules back for refurbishment. So you can see the basic concept here of how the whole drone fits together. Lots of parts, but very, very easy to maintain. The next thing we had to do is, so can you all see my mouse over there moving or not? No. Okay. So you'll see the motor mounts with the sticking off the front. It has a very, very unusual configuration, which works towards its efficiency, but that posed some interesting problems with regarding to tearing wings off. So we actually had to redesign how wings are built. And you can see here, the wing actually has a lattice structure inside. It doesn't have a conventional spar and rib structure. This has been a nightmare in itself to actually produce, and we've been working with SolidWorks to now produce the next generation of it, which is about to be implemented into the version 2 Airframe. So some of the innovative features that we built into this drone, we have blade locking. Now, when you have large propellers spinning in the wind, depending on the angle to the direction of flight, they create lift, and they can actually create unpredictable lift. You can stop them using your motor braking, but that uses power. So we actually designed a little servo that locks the blade, but also allows the blade to turn if it needs to, even if the locking mechanism fails. The next problem was multi-axis thrust control. So VTOLs have a tendency to drift when they're close to the ground, and they become very, very hard to control. So what we do is our rear motors can move independently. The latest version 2 actually has a horizontal stabilizer as well that moves, giving you 2-axis thrust vectoring on the back. We needed a modular payload bay. It's foreseeable that there will need to be payload changes done quite quickly. So what we've designed is a payload bay where all of the hardware required for a particular payload is in the bay. All you do is literally unclip a bay, clip a new bay in, all of the interfaces are the same to the drone, and you can change your payload. The drone is powered by the Cube Autopilot, and most recently, it's now got a GPU, an NVIDIA GPU for its AI. So it has an incredible amount of processing power on board. The other change that's come about since Kim last saw it is hybrid power. We're in the process of finalizing our own hybrid power system, which increases the flight time from about 3 hours to about 7.5 hours on the drone. And that's quite a substantial increase, and also it makes the drone easier to refuel. So where to next? Kim sort of said, well, where are we? When are we going to see the drone? I wasn't going to mention this, but it kind of came out today because the drone is very, very unique. Besides the supply problems and getting parts and manufacturing issues, we also got sidetracked by a humanitarian mission called Ukraine. We're part of a team that has actually designed a 3D printable airframe. What you're seeing there is our Teleraves 150 Falcon. It's a 1.5 meter airframe that can be 3D printed on any home printer. And it's purely surveillance. It's non-military. And these are being assembled at the moment and shipped over to Ukraine. And yeah, we try to keep it quiet, but it's a very distinctive airframe, so people realized immediately we're involved. Apart from that, we also had to expand the focus of the project. Just building a drone is not enough. The drone has a lot of dependencies and a lot of systems that has to implement or interface with. You've got pilot training, you've got the public, you've got civilian air traffic, you've got conservation scientists, conservation organizations, South African police, sandparks, air traffic control, civil aviation, ICASA, ground teams. So what we decided to do is expand the project build 15 drones that we're busy fundraising for at the moment to deploy at reserves around South Africa, with the aim of creating a blueprint for how to successfully implement drones into anti-poaching. It's going well. We've already touched base with quite a few organizations. We've got our fundraising kicked off. So hopefully within the next month or two, the first drones will be rolling out and be deployed. One thing, though, that keeps plaguing us is the South African landscape. If you're operating in South Africa, as Kim said, you're most probably buying your airframes from overseas. There's a few local manufacturers of airframes, but they're very, very high end. There is a big need for us to start making airframes and drones locally. COVID has taught us, COVID and Ukraine, ironically, has taught us that we need to be independent. One of the major reasons why we've been waiting for components is the 3D printing service we were using had a printer breakdown, and the parts that they needed to it were impacted by the Ukraine war. That gets us onto components. We keep hearing people say, we want to get into the drone industry, we want to build complete drones. Building drones is really expensive. There's no cheap entry point into the market. However, the one thing that every single drone manufacturer needs is components. And at the moment, just about every single component is sourced overseas. And there's absolutely no reason why we can't be making some of these components in South Africa. In fact, we have to start making them. Then you move on to integration. And when I mean by integration, autopilot integration. If you're using something like Autopilot, the skills required to integrate the autopilots don't exist in South Africa. You have to go overseas. So we're literally paying people overseas to do what people in South Africa could be doing. Flight tuning. There are very few people that you can hire to do flight tuning for a drone. You have to either employ them or, once again, get people from overseas to help you. Power systems for the drones, batteries, motors, chargers, simulation systems for the drones. With the Autopilot ecosystem, you can now actually create simulation models that fly very, very similarly to the real thing. But once again, we don't have the people locally with the skills. So that's a little bit of an overview of the project. And Kim, maybe if people have got questions, now would be a good time for people to ask.
Robert, thanks so much, and good to have an update, and also your keeping your humanitarian efforts quiet. Well done. It looks amazing what you guys have done, and some of the additional features are very exciting. You know, we hear comments all the time, and like you said, there are one or two manufacturers in South Africa, and everyone's like, oh, there's no one. And I was like, you just wait and see. You just wait and see when this is. So we are willing this project along, as I said earlier on. Well done, and huge congratulations. Yeah, Debbie says this is the most amazing project. So show us what you have.
So that's the Falcon airframe, printed on home 3D printer like this. I can't give you all the specs on it, but these things are being mass printed by people at home, universities, companies, suppliers all over the world are donating parts to them. And it's not a military aircraft. Its primary role is for civilians in towns to understand what's going on around them and to be able to evacuate if they need to.
Wow, that's incredible. That is incredible. Well done. So yeah, I mean, I guess my immediate question is, and I'm sure you would have answered it if you had an answer, but when might we see one of your models in action? And as you know, we are ready to test. We have a friendly client. We have a runway, which I know we don't need, but we have game. So when can we start testing?
Not to jinx it, the last parts are supposed to ship to us on Monday. Easter got in the way. They were supposed to ship to us tomorrow. I have, well, actually, let me show you. Here is the new fuselage section.
Oh, wow.
That'll be assembled this weekend. All of the wing sections are here. All of the electronics are here. All of the controllers are here. There are some engineered shafts that are still on their way, and those will be here by Monday or Tuesday. And then it's put it together and fly it, not crash it.
Oh, I don't think my nerves would be able to handle that first flight.
We're not expecting to have any problems. There's been a huge amount of effort put into simulation. I mean, barring a hardware failure, but everything we're using is state of the art.
Yeah. Actually, it's very interesting for those that are on the call who don't know. Robert, would you mind sharing with the group your activity in simulation and why that is so important when you are busy with design and testing and pre-manufacturing, and how that actually works? Because I've seen your presentation, and I was also in the room with the team who does that simulation. And so just for anyone who doesn't know, it would be really good for you to share that.
So just to answer, I see there's a question quickly from Debbie.
Yes.
What is the weight of the airframe and what is the payload capacity? The payload capacity is 1 kilogram, and the airframe weighs 5.5 kgs. So you have a maximum takeoff weight of 6.6 kgs on the 2 meter. The 4 meter that's on the drawing board at the moment is a whole different animal that has a 32 kilogram takeoff weight. So simulation, you mean simulation from the design point of view?
Yeah, so as you said, you know, you shouldn't have any problems in your test flights because you've done so much simulation. And I just wanted to share with the group what that means and what that practically means.
The CAD tools have come a long way from where they were 15 years ago. 15 years ago, you had to wind tunnel test. You couldn't actually, if you wanted to test something, you wanted to test your aerodynamics, you wanted to test your lift, you wanted to test your components, you had to either do physical stress testing or you had to do wind tunnel testing, which was really expensive. With SolidWorks now, you can actually test the aerodynamics within the CAD. You can test the airflow, you can test the stall speed, you can test the response to your control surfaces, you can test the strength of the structural components. So we have hundreds and hundreds of hours of simulation on the airframe. We're about 96 or 97% certain of what it's going to do. Simulating power, simulating load, simulating stress on all the shafts and the bearings. The initial test flight that was done with the Falcon a few years ago, that was also simulated. The airframe, it was molded out of foam and was thrown off Chapman's Peak with no motors to glide, and there were absolutely no problems with the flight at all. It performed exactly as we expected it. So simulation, we always say to people, the budget for this project in time and money has been 7 million rand to date to build the aircraft. We think it's a lot until you speak to people in the aircraft industry who say, well, you're building a small unmanned aircraft. That won't even basically pay our lunches for a year with them. It's a tiny, tiny budget. But if we weren't doing it in CAD, we'd be looking at 30, 40 million rand to develop this airframe.
Yeah. So just for anyone who's new to the industry, in layman's terms, instead of building a frame, flying it, testing it, crashing it, and then rebuilding it, flying, testing it, crashing it, which will then add to those millions and millions, very clever people have built very clever software, and all the components and all the measurements and all the flight scenarios are added into the system, and then the testing is done on the system with all the variables, and it will tell you whether it will fly or not. So it's just amazing to actually see when someone demonstrates, you know, those flights, that you're essentially not doing in a wind tunnel, you're doing them on a piece of software. So
just to answer Debbie again, yeah, Debbie, under 7 kilograms, the 2 meter was purposely kept light because of the CAA.
Yes.
For Louise, what are you expecting to use the larger payload capacity? I assume you mean the 4 meter. So the 4 meter is fuel and basically high resolution cameras, ultra high resolution cameras. The 4 meter will fly high enough that no one will know it's there, and potentially can fly for 24 hours. Right. So it will fly, and the only reason it comes into land is to refuel.
Gosh, okay. Thank you. I mean, is that's for surveillance, anti-poaching, the humanitarian, any sort of long-term surveillance option?
The 2 meter is really an anti-poaching aircraft. It's a small surveillance. 7 hours with the hybrid is now approaching respectable surveillance for other applications. The 4 meter is maritime patrol, anti-poaching, search and rescue.
Okay. Great. I mean, the maritime patrol is really important. I mean, you know, the fishing industry, that's a really important industry to keep an eye on, let alone all the other stuff that's going on out there. And I mean, the seas are pretty much uncontrolled and unmanaged. So that's a really important application.
Well, things like people have said, well, will you make them available for shark spotting? Because it's much easier to see a shark from the air than it is actually even from the beach huts. So there's lots of options: firefighting, conservation, head counts, deforestation. The sky's the limit, literally, with it. Debbie, 4 meter can basically fly, well, the 4 meter, you would, to not be seen or heard, I would say 2 kilometers, 2,000 meters. It is pretty quiet. They're all pretty quiet because all the motors are inside the fuselage and they're silenced. At 100 meters, you will battle to hear even the 4. Everyone's late.
We can. So, Robert, in terms of getting this aircraft through the type approval process and the CAA going, hey, this is awesome, you know, we can absolutely approve this aircraft for flight to 2 kilometers. What do you think you still need to do, and where are you guys on that?
So preliminary paperwork is being drafted. We didn't want to go to Andre until we had the final design, because CAA doesn't like you changing things. Next step is, in tandem with raising the money for the implementation at the first reserves of the experimental airframe, is to start registering the commercial airframe. That'll take a bit of time. But it's much easier with the experimental aircraft at the moment than with the commercial airframe.
Yes. And is your plan to register the experimental airframe with a CAA in the first instance?
Yeah, all of them will be registered. All of them will have tail numbers. Well, the budget at the moment is 12.5 million rand to build 15 of them and to register it.
So shall we just do a crowdfunding exercise here on Fireside Chat quickly?
So that would be great.
That's brilliant. And so we should, I mean, okay, so do you know, according to my sources, and I stand under correction, but no one has ever called on the registration of an experimental aircraft at the CAA, even though that process exists.
Yeah, I'm not. I mean, Sam and the guys would know that, but it's very possible. What the lawyer that we spoke to said, as far as the CIA is concerned, experimental aircraft flying over private land are a headache the CIA doesn't actually want to deal with.
But there is a process to deal with it, so they would have to, but no one's ever taken them up on it. So you will be the first.
We'll be the first.
And once it's done, we would like that breaking news right here on Fireside Chat.
Definitely. And because it's a transition aircraft, not a conventional VTOL, it falls very much in experimental category. So it's easy to slip it in along that avenue.
So do you want to explain to everyone here what transition versus traditional VTOL means?
So so traditional VTOL is an aircraft that takes off like a helicopter or a copter and flies like a plane. The standard way of doing it is to take a normal fixed wing, stick 4 motors underneath the wings, 2 underneath each wing, and still have a propulsion system at the back. So the problem with that is you're carrying an extra motor. You're carrying an extra motor during VTOL, and you're carrying 4 extra motors during forward flight. It's not the most efficient way of doing things, and it's also a problem because a lot of the fixed wings weren't designed to take off this way. I mean, you can modify an aircraft beyond its original design, but it's always best to design it from scratch. With the transition, they have tilt rotors. So you can either have a complete transition, which is everything out there at the moment, where all 4 motors can tilt. So they take off vertically, and then they tilt, all the motors tilt forward, and they transition to forward flight. Ours is a half transition. The front motors are only there to lift. So let me try and get the airframe for you. One of them, it's not going to fall apart. Okay, I'm going to get that one over there. So you can see there's these little pods under the wings. This is where the front motor mounts go into. Now, with propellers, you can either have, if you haven't got variable ratio or pitch on your propellers, you can either lift efficiently or you can fly forward efficiently. You can't do both. So you'll see the aircraft like the Osprey, that American tilt rotor, have absolutely massive propellers with variable pitch, trying to compensate to do both. Now, we apply the heavy light end of the fridge principle. And yes, there is a heavy end of the fridge. If anyone tells you that there isn't, there is definitely a heavy end of the fridge. So what we do is we have very, very big front rotors fixed in a downward position in front of the wing, very close to the center of gravity. So during takeoff, vertical takeoff, they're doing 90% of the work. Now, that means that we can offset our rear rotors really far back, the light end of the fridge. So they're not optimized to lift, but during vertical takeoff, they're doing virtually no work. All they're doing is balancing, so they're still efficient. And we only tilt the rear rotors, but we don't only tilt them 90 degrees, we can tilt them 180 degrees. So this aircraft has a unique trick. I don't know if you've seen movies where they're chasing a car, helicopter or plane chasing a car, and the car brakes and the plane overshoots it. This aircraft can actually turn its rear rotors 180 degrees backwards and brake. So if it's chasing a poacher or a poacher vehicle, all it does is spin up its front rotors, turn its rear rotors backwards, and it literally stops in midair. So it's quite a unique trick. And one of the reasons we had to redesign the shafts and the rear rotors is that little trick tore the rear motor mounts off.
Oh, wow.
Yeah.
So did that not give you a warning in simulation?
It kind of said it was on the edge.
Yeah.
But it was, yeah. When we were testing it, it didn't quite go according to plan.
Gosh, okay. Yeah.
But it's a very neat trick. The other thing that so the hybrid is running electric. It's running a gas engine onto a generator. The nice thing about it is this aircraft has no control surfaces. no ailerons, no tailerons, no elevators. It actually has little winglets on the, do I have them here?
This is such a show and tell. It's brilliant.
Yeah. Give me a second. Where are my parts?
Here's one I prepared earlier.
No, I'm trying to find my parts. I had them earlier. Anyway, our motor mounts at the back have stubby little winglets on them, right up on the tail, and it uses its motors to bank. It uses a combination of thrust, increasing speed on the motors, the rudders on the little winglets, and the angle on those winglets to control it. So virtually no moving parts. In fact, the simple version that's going into the bush, which doesn't have the rudders, has 2 servos. That's it. Minimal failure points, very easy to control. It's not an aerobatic aircraft. However, once you introduce the hybrid power and you can start up your front rotors whenever you want, the front rotors become ailerons. Mm-hmm. All you do to bank is just give a little spin on your front rotor.
Robert, there are some drone pilots on the chat, and in fact, some fixed-wing crewed pilots as well. What ratings will the pilots need to operate this drone, this aircraft?
It's an interesting
According to the CAA.
According to the CAA, we don't know because there's no aircraft like this. It's exceptionally difficult to fly with a normal radio. It has to be flown through autopilot because of the control systems on it. It can do things like change the angle of its nose, like a helicopter. So, yeah, that's going to be a little bit of debate as to what the CAA will accept, because most fixed wings can be flown directly with the radio. Here you've got the motor tilting, you've got the transition. It's quite a complex aircraft. BV loss is going to be a minimum requirement. We're hoping they're just going to go and say BV loss VTOL and not understand the rest.
Right.
But yeah. I think
and so from a controls perspective, are you going to have a control panel, joystick? How will it be?
We're using the HearLink system.
Okay.
Yeah. From a controls perspective with the HearLink, through the autopilot, it's like a normal aircraft. It flies pretty much like an aircraft. There's a switch to move it from copter to forward flight, to transition. So when it's in copter mode, it flies like a copter. When it's in fully transitioned, it flies like an aircraft.
Okay.
But you have to fly it via the autopilot unit. So you can't just say, okay, I'll go get myself a little Tyrannus and connect it up and fly with the Tyrannus. So it is easy to fly. I'm just not sure how the CAA respond to an aircraft that has to be flown via the autopilot.
Interesting. I'm sure Sam would be able to advise.
It's going to be an interesting chat.
And Sam's been doing some cool stuff with CAA. Hey, they're definitely on board with trying to drive the industry forward.
The idea of this aircraft really is that no one flies it. It flies itself. You tell it what to do, where to go, and it flies totally autonomously. One thing that you are going to like is we're talking to a company overseas about a backpack solution. So how many of you have ever been working inside, say, a caravan or flying inside a vehicle? Now you've got a control room. Now you want to get out of the control room and walk about. So how do you hand the control over from the control room to the remote station? These guys have produced a backpack with 2-meter aerials on the back of it. So you have phenomenal range by virtue of the aerials. You can even fit a directional antenna onto the top of it. And we're working with them that the backpack is the control station. You plug the backpack into the side of the vehicle and it transfers the control over to a second station at the desk. So all you do when you want to leave is literally walk outside and pick up the backpack.
That just seems, it sounds so geeky, but so cool.
Yep, it's a very nice solution.
Oh, brilliant.
There's lots.
So,
Debbie,
actually, oh, there you go. Debbie's just said, okay, so from a radio line of sight and in hilly areas.
Repeater stations.
Okay.
So the idea is to work with companies like Dimension Data, who are already putting in radio systems in reserves, using repeater towers, so that the drone has always got telemetry back to the base station.
Mm-hmm.
So that was an interesting question, actually, that got raised the other day. BB loss.
Mm-hmm.
If I have towers, say I've got a reserve and I've got towers all over the reserve, and the towers have a camera on it. Because let's be honest, when my drone is at maximum range from line of sight, I can't see it. I kind of see it, but it's a little dot. If your radio towers have cameras on them, and the camera on the tower can always see the drone, are you beyond visible line of sight?
Well, according to the regulations, line of sight means unaided visual contact with the drone by the pilot at the remote pilot station. So I guess no.
It's an interesting technicality.
But you'd be flying it on instruments anyway, right? So you wouldn't have to.
So the drone has camera systems. It's got forward-looking cameras. It's got thermal. It's got a 2K thermal camera and a 4K visual camera.
Mm-hmm. Okay.
So
and I know the questions that would come to you, and we face this all the time, and Lebo and Anna-Marie are on here, and they've been on one of our sites where it's been raining consistently. We've had so much rain in South Africa. In some areas, it is just crazy, and it grounds your aircraft because, first of all, you can't see anything because it instantly obscures the camera. So from a surveillance perspective, literally it just takes a few droplets of rain on the sensor and then you can't see. And secondly, even though the drones are IP rated, the cameras are not. And so, you don't operate. So I know the questions might come from a position of how weather resistant it is. Can you share some of that?
Yeah, very weather resistant. The cameras, we're using the Next Vision cameras, the Nighthawk and the Raptor. They're all IP rated. Thermal cameras can still see in the rain.
Mm.
They don't have the same problem as visible cameras. So you will always be able to fly. And actually, thermal cameras, if you're looking for people, are great in the rain because the ambient temperature drops, which means people get hotter as far as the camera is concerned. So it's actually easier to pick them up if you do that. The drone has a dust rating. Now, it's interesting. It's only a problem if your electronics get wet. You don't have to waterproof the entire airframe. You just have to waterproof the electronics bay, and you have to leave holes for the water to get out of the airframe. It only has to be watertight if it's a submarine. So the airframe is dustproof. The electronics are waterproof, but the airframe itself is not waterproof. But yes, it can fly in the rain. It has no problem with wet weather. Oh, you're muted, Kim.
That's great news. That's good. Let's quickly have a look. There's some comments here. Louise says, perhaps the towers with cameras would be viewed as observers electronic observers. I suppose it depends on whether the CA wants to keep humans involved.
Well, there'll always be a person watching the camera feed. So the pilot will always see the drone via the camera. So the pilot will always see what the drone sees, and will, if the camera's on the towers, will always be able to see the drone. Transponders, yes, ADS-B. All the aircraft have ADS-B receivers. Well, we're also looking at camera systems, collision avoidance cameras.
Mm-hmm.
But as you were saying, Kim, they don't work in the wet. We've been talking to the LiDAR guys. They're the ones who are actually sitting on the technology we need, but companies like Lightware are just not getting there yet.
Well, and they are quite cutting edge, right? So if they aren't,
so I think the problem came in. The authorities want you to identify what's in your flight path. So you've got the iris system that tells you if it's a Cessna, if it's a Caravan, what's there. We took a different approach. If there's anything in our flight path, we don't care. We want to get out of its way. It doesn't need a positive identification. We just need to know that there's something there that we don't want to hit and don't want to hit us. It's all very well and good to say it's a Cessna, but you don't need to know that. You just need to know there is something there.
That's Debbie's question. Very good question.
Only receiver, ADS-B receiver, not transmitter.
So it's in, not out.
It's in, not out. So it's looking for traffic around it.
Okay. Well, so that's what we have already now, right? We have in and not out. Yeah.
We're too small to carry out.
Yeah.
And quite honestly, drones shouldn't be carrying out. The aircraft around us should be carrying out.
So interestingly, we've had some operations in controlled airspace recently where everything gets approved. And I mean, we operate, let's say, at less than 100 meters. And everything gets approved. Flight plan gets opened after flexible use of airspace gets approved. And then ATC on the day says, no, you need a transponder. We need to be able to see you. So it's interesting. We're having some very, very interesting conversations with ATC and KMU about this, because, you know, how do you put a transponder? Where do you put a transponder on a Mavic Advanced for a small operation?
And also, a lot of the ATC towers don't have ADS-B capabilities. So what transponder? What transponder do they want you to put on?
Yeah, I don't know. Mode C? No, it can't be. We can't
carry most of the equipment. That would be on the 4 meter, most of its payload capacity gone.
Correct. Yeah. That's what I'm saying. So that was our conversation with these guys last week. We're like, where would you like us to put a transponder on a Mavic Advanced?
Yeah. But they should. So one of the big things that's missing is UTM.
Oh, 100%. Of course.
That solves the problem, because if the air traffic, if there wasn't UTM system in South Africa and ATC had UTM running, they would know exactly where you were.
So Robert, you and I had this discussion a year ago.
Yeah.
Don't think anything's changed since then.
No.
It literally was April, I think. It was literally a year ago.
No. Fire and ice.
Yeah. Let's quickly see. There's other conversation here. So Debbie says if aircraft has ADS-B, then surely it would be visible to criminals using standard cell phone apps.
Not if it's only in.
Okay. Oh, you said that. Yeah. Okay. How would it then integrate with other legitimate aircraft in the area? We obviously don't want to crash into another aircraft, but we don't want the drone to move out of the area due to the other aircraft.
That's a problem. So one of the things that we looked at in Hoedspruit was working together with the military and the police. that the second there's an anti-poaching operation, not just a patrol, an actual operation, there's a NOTAM issued.
Yes.
The area around where the drone is operating becomes a no-fly zone for civilian aircraft. That's a problem because the procedures that are required for that don't exist. In fact, the procedures for the police to work with the drone don't exist.
Yeah. Okay, Debbie. So I was going to just respond to that, but Debbie's hand is up. Go ahead, Debbie.
Yeah, thanks for that. So, I mean, the NOTAM takes too long to be issued. So if you're operational for anti-poaching, it's reactive and it's immediate, which is a problem that we've had with a lot of the authorizations that we've needed so far. And I'm using KZN Wildlife as an example here. In our situation, we're not worried so much about civilian aircraft because in theory, not necessarily in practice, they're not in our airspace. They shouldn't be flying over our reserves. But we do have our own aircraft that get deployed. So we've got fixed wings and helicopters that respond. So now I've got legitimate other aircraft, manned aircraft coming into that point, and we're homing in on the same area of where the incident is. And we all need to be in that same space legitimately, and I'm just scared that the drone would go, oh hell, there's two other aircraft coming in, I'm out of here. And the NOTAM is not going to help us at all.
So with your aircraft, that you will know where the drone is at all times. All of your aircraft, by virtue of the fact that the drone is broadcasting on encrypted frequencies, will know where the drone is. You will have the exact GPS and height coordinates of it at all times. For night operations, the drone has a black IR beacon. So any infrared system can actually see it, but only from above. You can't see it from below. And hopefully it's actually flying low enough that you're always going to be above it. But yeah, Debbie, it is a big problem. At some of the reserves we are talking to up in the Hoedspruit area, there should be no aircraft after a certain time because the tower closes. But that doesn't stop Oom Pitt and his family flying in to visit the reserve with absolutely no clearance. Luckily, in those areas, it's military airspace. So we've had an indication from the Air Force Base saying, just give us a call and we'll make sure no one's in the air.
Yeah, that's helpful because the other thing is in our reserve, it's very hilly. So you know, your height above ground level is changing all the time. Which then just makes it more difficult because you've got terrain avoidance that you have to build into it along with your other manned aircraft. It's going to be tricky, but yeah, not insurmountable.
We have LiDAR as well on board, so we always know exactly how high we are above the ground at any one point.
Very cool.
It's a very, I must say, and it's not just because it's ours, it's a very, very cool aircraft. It's a very, very expensive aircraft, which is why your point's taken. We would like not to lose them if we could help it.
Yeah, Debbie and Robert, yeah, you guys raised some really good points. Just to kind of practically speak to some of those. I mean, we have to issue NOTAMs for any BVLOS operations we have. And, you know, the system's working well, but yes, there is a lead time. I know I'm probably going to get shot for this, but I can almost guarantee that private pilots don't check NOTAMs. So we really do that to satisfy the regulations, but we cannot rely on NOTAMs for safety and the reliance of pilots actually checking. And specifically in private reserves, there are some private pilot cowboys out there who just don't care. They're not on the radio. I mean, I don't even think they would know what an OTAM is. I mean, maybe they would know, but they might not even know where to go and look for them.
I completely agree with you. It's shocking, actually.
Yeah.
So Debbie, if the CAA had actually enforced all civilian aircraft carrying ADS-B, which is what they were trying to do at one stage and had been proposed, that's very easy, because once the drone has a companion computer on board.
Mm-hmm.
It's got an exceptionally powerful NVIDIA GPU.
Mm-hmm.
It's not actually hard to write software for it, that the second it picks up ADS-B, it can actually broadcast to that aircraft. So if it knows you there, it can tell you that there's an anti-poaching drone operating and to please leave the area. But the problem is, with no ADS-B, we don't know they're there.
Yeah. No, it's I mean, until UTM or some form of separation or communication is brought in, it's still going to be risky for sure. Yeah, and as I say, Robert and I spoke about this last year, and I don't think anything has changed.
No, it's moving very slowly.
Moving forward to even, I may be talking out of turn, because there may already have been, because I don't sit on that specific working group, but I know the conversations are happening, and I know there is a working group that meets regularly, but I don't know yet whether the decision has been made on a specific UTM model or U-space or whatever. They haven't even, determined what it's going to be called. So
it's kind of impossible, because on the one hand, you have the proprietary drones like DJ drones. Then you've got the Parrot drones. Then you've got the cheap Chinese drones and the Indian drones. You have so many drones that are available. And this is the problem. I know everyone's saying, well, you can't tell us we can't have drones. Well, actually we can. You have aircraft. You have an aircraft that's in space with other aircraft. Yes, we can tell you can't have a drone that doesn't fly. We can't bring a cell phone or a radio in without ICASA approving it. Mm-hmm. Why can you bring a drone in without CAA approving it? Mm. Because no matter what we put in, these drones will not be compliant.
Mm-hmm. Yeah, exactly. And I mean, with things like law enforcement, with things like quick reaction, with things like anti-poaching, to our topic tonight, speed is of the essence, and we can't wait for approvals. And if some air traffic controller, which we've experienced now a few times in the last while, decides that not on my watch, what they say goes, and it's a very manual process, and it's definitely not something that's, in fact, we operated in Cape Town controlled airspace a couple of months ago, and we literally opened the flight plan that morning. Everything was approved, and the ATC said there's another drone operating in that area. We can only have one drone operating in our space at a time. You need to wait until they finish their detail. And we were like, what? Where is that drone? They couldn't tell us, or they wouldn't. And so we said, this is a commercial operation. We have to do this. We have had the approval. This is the limit within the this is our operating area. And I think they heard that the pilot was well experienced, etc., and they let it go ahead. I actually think I might, or maybe the other drone operation had finished by that time anyway. I'm not actually sure on that detail. I wasn't part of that conversation, but that's what they said. So it's crazy. It's too manual.
But this goes to what we are saying in my talk about local skills. Now, you can stick a Raspberry Pi into any open source drone. Mm. Okay, the Pis and the Jetsons all use very similar coding language. Mm. It's not difficult for us to build systems whereby the drones can broadcast, like an anti-poaching drone can actually tell the tower it's tracking a target. The second it happens, that's there. We're just not using these features that we have because we don't know how, we don't have a framework to do it. But then again, I think the problem is if you're tracking a poacher and there's one rhino, does air traffic control care enough about a single rhino to disrupt or to make their life difficult and disrupt air traffic? That's the other problem. We do, but I'm not sure they do.
We definitely care, and they don't. I mean, we have operations where we're tracking criminals. They don't. They for them it's about safety, and I get that. You know, we can't, I guess, influence what they interpret their regulations to be, using, you know, the tugging on the heartstrings or whatever. I get that as well. But yeah, you know, it's concerning for us, but not for someone who's responsible for, you know, keeping the airspace clear or safe. This hour has just flown by. Robert, thank you so much. We haven't spoken in a while. I'm so glad personally to know your updates, and so glad that you could share it on the Fireside Chat. Let me just see if there are any more questions here. I think we answered all of them.
I've just posted my email address, Kim, in case anyone wants to drop an email. Yeah. Perfect.
Yeah. And also I had posted your LinkedIn profile for anyone who wants to connect with Robert, and please connect with each other as well. It's very effective, having a network and having people that, you know, you might not have spoken to directly, but you know, you've seen their names or what have you on the chat. Is Debbie still on? Oh, you are still on. Debbie, you asked about new topic. Sorry, you said, I'm interested in how you got FUA and flight approved for the work you're doing in KZN due to the flooding, permissions gained. Yeah, so excuse me, very quickly. So we've had a team down in KZN, which is an area in South Africa that's been very, very terribly affected by floods, flash floods and mudslides. I think we're sitting at over 300 deaths, lots of roads broken, washed away, highways. It's crazy. And we do work exclusively for one of the biggest insurers in South Africa. And so we have a contract with them. When something like this comes up, that we immediately go and deploy to that area. And the three major sites that we surveyed yesterday and the day before were luckily in uncontrolled airspace. And so if that had been in controlled airspace, we would have to have applied for FUA first and waited for that. And we might have actually only been operating tomorrow. So in search and rescue, unless there is a letter of procedure in place like there is in Cape Town with the Western Cape Government EMS, they don't have to do that. They do it retrospectively. They have an agreement with ATC. We haven't got that dispensation because we are not, we're not official search and rescue. So luckily for us, the sites that we had to go and survey were in uncontrolled airspace. But this is the challenge we have in South Africa, is we cannot respond as private commercial operators to things, you know, at short notice if it's in controlled airspace. We wouldn't have been able to do it. Oh, we would have been able to do it, but not the very next day. That answer your question, Debbie? Yeah. Yes, thank goodness. And honestly, I can't share the images because of course it's involves you know, information and footage that that is going to be used to decision very large insurance claims, business continuity or business disruption and damage. But it's shocking. You have no idea. It's bad. It's bad. Yeah, lots of people have lost their homes. property. And of course, the commercial properties are insured, right? So it is bad because it will affect people's jobs as well indirectly. But yeah, the footage is actually quite sobering. We are over. It is a long weekend. It's Easter weekend. For anyone, who's celebrating, observing, have a lovely long weekend. For anyone going away, travel safely. And thank you so much, Robert. Thank you, Louise. Thanks, everybody. Thanks for your interaction as well, Debbie and Louise. Have an awesome weekend. For my peeps who are working, hang in there. And we will see you next week. Bye, everybody.